In this video, we will discuss volume and surface area. A prism is a three-dimensional figure with polygonal bases, ends, that are parallel and faces, sides, that are parallelograms, rectangles, or squares. In a right rectangular prism, the faces are perpendicular to the bases. A right circular cylinder is a three-dimensional figure with a curved surface and two circular bases, such that the height is perpendicular to the bases. In an oblique prism or an oblique cylinder, the faces are not perpendicular to the bases. The height of a prism or cylinder is with two bases is the shortest distance between the two bases. In right circular cylinders and in right rectangular prisms, the height is the same as the length of a side or face. However, in oblique prisms and cylinders, the height is the perpendicular distance between the bases and is shorter than the length of a side or face. The volume of an object, such as a container, is used to estimate how many containers can be loaded into a given size storage area or shipped in a container of certain dimensions. A volume of a three-dimensional geometric figure is the amount of space it occupies, measured in terms of three dimensions: length, width, and height. Volume is expressed as a cubic measure. A general formula can be used for the volume of any right prism or right cylinder. If the base of the prism is a triangle, trapezoid, or other polygon, we can use the appropriate formula for the area of the base. The formula for the volume of a right prism or right cylinder is V equals BH, where B is the area of the base and H is the height of the prism or cylinder. For example, find the volume of a right prism with bases that are equilateral triangles with sides of length 3 centimeters and height 2.6 centimeters. The height of the prism is 15 centimeters. The volume of the prism is given by V equals BH, where B is the area of the triangle and H is the height of the prism. The area of the triangle is given by A equals 1/2 BH, where lowercase b is the base of the triangle, which is 3 centimeters, and H is the height of the triangle, which is 2.6 centimeters. The area is thus 1/2 times 3 times 2.6, which is equal to 3.9 centimeters squared. Then the volume of the prism is V equals 3.9 times 15, which is 58.3 cubic centimeters. What is the cubic inch displacement, space occupied, of a cylinder whose diameter is 5 inches and whose height is 4 inches? Round to the nearest tenth. Since the diameter of the cylinder is 5 inches, its radius is 2.5 inches. V equals BH, which is pi r squared times h, which is pi times 2.5 squared times 4, which is equal to 25 pi, which is 78.5. The displacement of the cylinder is 78.5 cubic inches. A right cone is a three-dimensional figure whose base is a circle and whose surface tapers to a point called the apex. The apex is the vertex formed by the sides that is the tip of the height, and the height is the perpendicular line segment between the base and apex. One example of a cone is the funnel or the circular rain cap placed on top of stove vent pipes extending through the roof of some homes. A pyramid is a three-dimensional geometric shape that has a polygon for a base and lateral faces that are triangles with a common vertex, the apex. The height or altitude of the pyramid is the perpendicular distance from the vertex to the base. If the base of the pyramid is a polygon that has all sides equal, such as a square, the height meets the base at the center of the base and is a right or regular pyramid. The volume of any cone or pyramid is V equals 1/3 BH, where V is the volume, B is the area of the base, and H is the height of the cone or pyramid. Find the volume of a pyramid that has a height of 28 centimeters and a square base that is 15 centimeters on a side. Because the base is a square 15 centimeters on a side, the area of the base is B equals 15 squared, which is equal to 225 cubic centimeters. That should be square centimeters, sorry. So the volume is 1/3 BH, which is 1/3 times 225 times 28, or 2100 cubic centimeters. A frustum of a cone is a part of a cone between the base and a plane, passing through the cone parallel to the base. Similarly, a frustum of a pyramid is a part of the pyramid between the base and a plane passing through the pyramid parallel to the base. The volume of the frustum of a cone or pyramid is the V sub frustum, which is equal to 1/3 H times B1 plus B2 plus the square root of B1 times B2, where V is the volume, B1 is the area of the base, B2 is the area of the top, and H is the height of the frustum. Find the volume of the frustum of a pyramid with a square base that is 4 inches on each side, a square top that is 2 inches on each side, and a height of 3 inches. We can easily calculate the areas of the bases of the frustum. B1 equals 4 squared, which is 16 square inches, and B2 equals 2 squared, which is 4 square inches. So the volume of the frustum is 1/3 times 3 times 16 plus 4 plus the square root of 16 times 4, which is 20 plus the square root of 64, since 1/3 times 3 is 1, which is 20 plus 8. So the volume of the frustum is 28 cubic inches. A sphere is a three-dimensional figure formed by a curved surface with points that are all equidistant from a point inside called the center. A great circle divides the sphere in half at its greatest diameter and is formed by a plane passing through the center of the sphere. Notably, spheres hold the greatest volume for a specified amount of surface area, so they may be used to store gas and water. A sphere does not have bases like prisms and cylinders. Because of the relationship of the sphere to the circle, the formula for the volume of a sphere includes elements of the formula for the area of a circle. The volume of a sphere is equal to V sphere, the volume of a sphere, which is equal to 4 times pi r cubed over 3, where r is the radius. Note that the radius is cubed, or raised to the power of 3, indicating volume. Find the volume of a sphere that has a diameter of 90 centimeters. Since the sphere has a diameter of 90 centimeters, its radius is 45 centimeters. So V equals 4 pi r cubed over 3, which is 4 pi times 45 cubed over 3, which is 381,704 cubic centimeters when rounded to the nearest whole cubic centimeter. The surface area of a three-dimensional figure can refer to just the area of the sides of the figure, or the overall area including the bases along with the sides. The lateral surface area, LSA, of a three-dimensional figure is the area of the sides only. The total surface area, TSA, of a three-dimensional figure is the area of the sides plus the area of the bases. The lateral surface area of a right prism or right circular cylinder is LSA equals PH, where P is the perimeter of the base and H is the height of the three-dimensional figure. The total surface area of a right prism or right circular cylinder is TSA equals PH plus 2B, where P is the perimeter of the base, H is the height of the three-dimensional figure, and B is the area of the base. Find the lateral surface area of a rectangular shipping carton measuring 24 inches in length, 12 inches in width, and 20 inches in height. We can use our formula for the perimeter of a rectangle to get the information we need to complete this problem. The base of the carton is a rectangle with L equals 24 inches and W equals 12 inches. Therefore, P equals 2 times L plus W, which is 2 times 24 plus 12, which is 2 times 36, which is 72 inches. Then LSA equals PH, which is 72 times 20, which is 1,440 square inches. Find the total surface area of a triangular prism with bases that are equilateral triangles with sides of length 3 centimeters and height 2.6 centimeters and lateral height 15 centimeters. The perimeter of the triangle is the sum of the lengths of its sides. The sides are all 3 centimeters, so the perimeter of the base is 9 centimeters. The area of a triangle is B equals 1/2 BH, which is 1/2 times 3 times 2.6, which is 3.9 centimeters squared. So the total surface area is pH plus 2b, which is equal to 9 times 15 plus 2 times 3.9, which is 135 plus 7.8, which is 142.8 square centimeters. A sphere does not have bases. Like its volume, the surface area of a sphere is based entirely on its radius and includes all the surface, so there is only one formula. The total surface area of a sphere is TSA equals 4 pi r squared, where r is the radius. Excuse me. Find the surface area of a sphere that has a diameter of 90 centimeters. Since the diameter of the sphere is 90 centimeters, the radius is 45 centimeters. So TSA equals 4 pi r squared, which is 4 pi times 45 squared, which is 25,447 square centimeters when rounded to the nearest square centimeter. The slant height of a cone is the distance along the side from the base to the apex. The lateral surface area of a cone is LSA equals pi rs, where r is the radius of the circular base and s is the slant height. The total surface area of a cone is TSA equals pi rs plus pi r squared, where r is the radius of the circular base and s is the slant height. Find the lateral surface area and total surface area of a cone that has a diameter of 8 centimeters, height of 6 centimeters, and slant height of 7 centimeters. Round to hundredths. Note that there is extraneous information in the problem description. No part of either LSA or TSA requires the use of the height of the cone. Since the diameter of the base is 8 centimeters, the radius is 4 centimeters. So LSA is equal to pi rs, which is pi times 4 times 7, or 87.96 square centimeters. TSA equals pi rs plus pi r squared, which is pi times 4 times 7 plus pi times 4 squared, which is 138.23 square centimeters.